Okay, the Mig Welder. So here at the school we have Lincoln Electrics. We run 180Cs and 140Cs. And then everything that's like specialized welding, we have Pro Spot or Caroliner stuff, right? So this is good old trusty welder number 2. It's set up for 20 gauge sheet metal for auto body repair. Runs 0.6. 023 welding wire, ER 0.25, ER 70-6, ER 49S6, ER 70-6 wire, right? So that's the wire for doing collision repairs, unless you work for a specific kind of car that calls for something else. We've got mixed gas on it. This gas is argon CO2, and it should be 75-25, but I'm not 100% sure. But this is the mixed gas for welding steel, regular steel, right? So we'll hook this welder up and get it running. So again, these are kind of like a barbecue connection. You can see where it seats, right? It's all soft brass, so it seals very, very well. But again, you always want to go backwards first with the threads and then go forwards. You hear the click, you know it's on the first thread, and then go forward because they are soft. These regulators aren't especially expensive, but they will literally last forever if you don't abuse them, right? So you just snug it down to make sure it's tight. You don't have to go crazy. We'll spray some soap and water on there and make sure it's leaking. Argon and CO2 are really an inert gas. They're not flammable, they're not poisonous. So if it did leak, the only thing that would suck is you'd be changing the bottle more often, right? These bottles, by the way, are almost always on a rental. They have to be recertified. They only last so long. They have to be hydro tested and all this stuff. So what all the body shops do is they rent the bottle and they just pay for the gas inside. So there'll be a yearly rental on a bottle like this. It'll be like 75 bucks or something like that. And then it'll be 75 bucks to fill it up or something like that. I don't really know. I have three bottles at home. I don't even remember what they cost. So we got the gas hooked up. The gas line's into the back of the machine. This machine's been run before. It's not new out of the box, so we don't have to put together too much stuff. But it does not have wire in it. So I'm going to show you guys how to load a wire and run a wire through the machine and how all this stuff works. So regardless if it's a Lincoln or not, they're all pretty similar, right? So you get a spool of wire. You order these by pound. I think this is a 10-pound. I'm going to say it's a 10-pound roll. The bigger machines can take even bigger ones. And the bigger they are, the cheaper they are by the inch, right? It's got the do not eat packet inside it, so it can't go rusty. And although when you look at the Mig Wire, it is, it's certified. By somebody, not sure who. But if you look at the wire, it looks like it's made out of copper, but it's actually steel, right? And it's a specific steel, depending on which one you order. This one's ER 70-6 for strength, how much carbon's in it, and all kinds of stuff like that. But this is steel wire. It has a copper coating on it that does two things. It stops it from getting corroded. Also why the silica pack's in there, also why it's wrapped in plastic, so it doesn't corrode. If you have oxidization or rust on the wire, you can't make a nice weld with it. And the other thing is the copper is very slippery and slidey, so it slides through the liner of the whip to the end of the gun very, very well and creates an excellent electrical contact to the copper tip on the end. It stops the drive rollers from wearing because the copper is nice and soft as well, right? So our spool is spinning this way and we want the wire to come off the top and feed into the rollers. You can see how they're on an angle there. So I got to flip this around like that. And I'm just going to pull this up so I can grab it. And you can see there's a little hole there, like a peg. So that little peg hole is supposed to line up with this little peg over here. So we're going to stick that on and get it in the little peg, okay? Now we're gonna take this and pull it off. I always keep my hand on it because I've had these unroll before, and man, does it suck. It's like when your little brother grabs your slinky and pulls on it when you're a kid, you know? I don't know if you guys had slinkies. Anyways, so I like to hold it like that. Some people like to put a piece of tape on it, and we're gonna feed it through the drive rollers into the other side, like so, and feed it into the whip. I don't know, I hope you guys can see it. Turn me up. Okay, so I got it going through there. This is the one drive roller. That's the other one on the other side. You can see they're geared together. And this is the whip inside here. This knob actually holds the whip in, and the end there is the liner that carries the wire up to like the torch handle and the contact tip and the nozzle to create the weld, right? So we don't want to kink it up. There we go. Okay, so it slips in there. The drive rollers have to match the wire side. This 025 has to have an 025 wire. There's a little groove in it with little grips that grab onto that wire. And if you switch up to a bigger wire, 030 or 035 or something like that, you need to change the little drive rollers, right? So this guy comes down, and this little spring-loaded knob applies pressure to the rollers for it to grip the wire. And then there's a little anti-bird nest thing, right? So bird nesting is when the wire gets stuck at the torch, the drive rollers push it, and it just sort of bunches all up inside here, right? So a lot of newer welders have this anti-bird nest thing, so the wire can't get away. And you can see where the wire's been rubbing on here, and it's transferring the copper, that slippery copper, over. And it's got an arrow on it, so you can't put it on backwards. Make sure everything's nice and tight. These are the continuity connectors, so you can make it negative or positive. It's a DC welder. So if you look at this thing here, it's like the little cheat sheet. You can set it up DC negative, DC positive, or DC positive even for aluminum, right? So we're using the mixed welding gas. We're running 025 wire. So this is sort of like a cheat sheet for you, a little welding setting and setup. So it's saying like if you're welding 20 gauge metal, right, 24, 22, 20, you're using the mixed gas with 025 wire, you want to start around 1.5 and D. So you would set it to D and 1.5-ish, and then you'd tweak from there, right? If you're wondering what kind of metal you're actually welding, you can take a piece of metal and you can set it up at this thing and go, is it thicker than 22 gauges, 20, 18, and this one is 20 gauge steel, and you can see it's the same thickness. And this welder will, even though it's just a small welder, but it's 220, this 180 welder will weld up to 3/16, right? So you set it to 4.5 for drive roller speed, and for the voltage, you just crank it right to the top, as far as the alphabet will go. But you have to run 035 wire, right? So for our 20.25, our 0.6 millimeter wire, the thickest stuff that we can weld is 10 gauge, which is real thick. That'd be like welding like a subframe or something like that, which we're not even allowed to weld on cars. So any frame rail, any cross member, any rocker panel or anything is not going to be as thick as 12 or 10 gauge metal, right? Okay, so these are really good machines. They work really well for collision shop, and it's not too big, doesn't take up too much space, and they weld beautifully. Like, I have no problem using one of these. I actually have one of these at home too. Mine's one of the 110 ones, though, not a 220. But that's we got that wire through. Now we gotta get the whip. And when you're feeding the wire through, you want to make sure that the whip doesn't have any tight turns in it. And we got to take the gas nozzle off, and we got to take the contact tip out. because as that wire is coming through, it'll bang into the end of this, right, instead of coming through. And the liner, I don't know if you can see it, but the liner's inside there. It looks like a coiled piece of metal, like a tube that it runs through, right? So we'll fire this sucker up, and we'll go to maximum wire speed, and the drive roller should feed this through. And you can actually, I can feel it coming up the handle, so it's almost up now, and there it is, right? So now to keep going, to put it back there, we just slip the contact tip over top, screw it in. These can come loose because they get very, very hot. So you do just snug these down. They're consumable, so it doesn't really matter if I mark it with pliers. Although there is specialty Mig Welder pliers that are awesome. You can get them anywhere, Canadian Tire, Princess Auto, and they actually have like the different sizes for grabbing the cone, for grabbing the contact tip without squishing them, because they are soft. You can see the pliers already made marks on it, right? So now what we want to do is set up the drive roller tension. So we got our wire loaded, we got our gas hooked up. We won't turn the gas on yet, I'll get that done in a minute, okay? But we do want to figure out how our drive roll tension is, okay? So how we do that is you set up your stick out, which almost perfect if you have a pair of needle nose pliers or the Mig Welding pliers, is you just make the cutting part on the outside and snip it. It'll be pretty much the perfect length to start welding. And what you do is you take a welding mitt and you just stop the wire, and it should stop. Okay, so it's a little too so there, see how it's slipped? That's what we want. We want it to be able to slip and not grip, right? So what you do is you grab on about 2 inches to the sticking out, and you want it to be able to push, okay? Push the wire to bend it, okay? We don't want it to push my fingers. I want it to bend the wire. So it was slipping there, right? So it needs a little more tension, a little more traction on that wire. So I'm gonna grab 2 inches again, about out, hold it, and I want it to be able to push the wire and bend it. There we go, it's pretty much perfect now. So it didn't slip, it just pushed, but if I hold it, like really hold it in, it will slip, right? So we know it won't be able to bird nest, and it won't stop coming out and cause a burn back into the tip, right? So that's how you set up a welder. So we want it to be tight, but not too tight, right? If you have it too loose, it'll slip while you're doing regular welding operations. It'll mess up your weld, right? If you have it too tight, when you're welding and it burns back to the tip, you'll have a big messy bird's nest in here, and it'll be much easier. Instead of just cleaning it up at the end of here, we're gonna have to pull it all out and run the wire through again, right? So about 2 inches out, should be able to push and bend the wire. That's perfect, right? Put our pliers on, and away we go, okay? So now this sucker should be ready to weld, right? So again, up here, we got 20 gauge, 1.5D is where we're gonna start for welding. We'll introduce some gas. D 1.5. Oh, somebody left this on. So we got about 1,000 PSI in that tank, and we want this. This is in pressure now. This is CFH, cubic feet per minute, or liters per minute. We want about 10. 10 is all we need in order to MIG weld properly around there, right? So we got gas coming out to shield the arc. We got wire coming out as our filler rod. And then we just need our continuity clamp to clamp onto our piece of metal, and we'll be able to do some welding. Now I do have to go and get a welding helmet. Let's set up some welding shields. So I'll be... Okay, I got a GoPro stuck to the welding helmet. So hopefully you guys can see what I'm doing. Looks like it's working. So I'm going to do a couple of MIG welds, and I just have it set to the settings that the inside little cheat sheet said to use. So we're going to see how those go. I'm going to do 4 beads on this coupon. I'm going to do 2 pushing and 2 pulling, and we'll see what happens here. So when I'm going forward like this, that's pushing a weld. When I'm going back like this, I'm pulling the weld, right? Okay, let's see. Push again. And you try to go the same speed, the same distance, the same angle, to try to get a consistent and even weld, right? And that's basic welder setup, right? So let's take a look at this. Okay, so we got 4 beads. They look pretty close, but really the outside of the bead means very little. It's the inside. So if we look at the bottom, we can see what is actually going on, right? So I'll point with this wrench, I guess. So we can see the first bead at the top. Let's see, so I started over here and went along. Yeah, so I went this way because it's upside down. And you can see there's not very much penetration, and it's not very even. And then it gets more penetration as it goes along. What's actually happening there is the coupon was cold, and as the heat melted and heated up the coupon, was preheating the coupon, then the weld started to sink in, right? This one you can see the weld is very even all the way across. And this is how you tell if you're doing the weld correctly or not. It's not the top, it's the bottom. So it's very important that we test our welds out first, because when you weld a car up, you can't see the inside unless you stick a borescope in there or something like that, right? So this is a push going in that direction. You can see it, the coupon heat up. There's nowhere for the heat to run off of the top of this, so it gets very hot at the end, and it'll always be more penetration, right? On a car, that doesn't happen because there's going to be more car over here, right? This one here was the pull. You can see the pull is more consistent as we go across, and then you can see a little extra penetration at the end. This is the push, and you can see it's a little bit fatter, a little bit wider, and then this is the pull going back. And you can see those last 2 that I did is very similar heat in the coupon, very, very similar travel speed and everything too. And you can see the welds look different. Welds are almost like fingerprints or snowflakes. Like every time a weld is done, it's a little bit different. And us here at the school, we can actually kind of tell welds from apart, like who did it. Like after you've done a bunch of coupons, we can say, oh, that's Brian's weld. This one looks like, you know, Robert's weld. And this one looks like Rebecca's weld, like whatever, right? So it's not just the top, it's the bottom, right? Really, all 4 of these welds are junk. Like they wouldn't pass any sort of OEM certification or anything like that because there's small little gaps in them. There's either too much penetration, missing penetration, not enough penetration, so on and so forth, right? That's how you actually read a weld, is you look at the backside. But you can see the settings on that weld are actually pretty decent for the baseline cheat sheet. Not too bad, right? That thin wire, you can see the travel speed is quite slow because there's not very much electricity and there's not very much welding wire going in, so it's a little slow, right? But that's how we weld 20 gauge sheet metal, right? And then at the end there, you can see I welded too close to the edge, nowhere for the heat to go. It just blew a hole through, right? So, I don't know, in a couple of weeks, there'll be more videos of all the welding screw-ups and how you do the different types of weld. But that's all we're gonna do for now, is just the simple setup, right? So we'll do another one with the welder setup. So I'm gonna show you what happens now if we don't have enough gas, okay? So this is a weld with not enough gas. So that is called porosity. So that's the actual oxygen and the nitrogen getting at the weld. There's no shielding gas to protect it, right? So I turn this back up, you'll see the difference. So you can see now it's clean, there's way less splatter, and it actually has strength, right? This weld would be very, very weak, very, very brittle. It's like a cracker when it's done, right? So let's see what happens if we do too much gas. So not a whole lot of difference really, and there's not a lot of difference in anything that's going to happen. Like basically all what you're doing is wasting gas. Sometimes what happens is the air is swirling and flowing around so much because the argon or the mixed gas is coming out so aggressively, you can actually get some porosity from the oxygen mixing in with it because it's just being blasted around too much. But you can see the difference between 10 CFH and what does that say? Like a zillion CFH, there's almost no difference, right? So it doesn't make sense to run more gas than you need. The tiny little bit is all we need to do the weld without making any difference at all, right? Sometimes you have to turn the gas up like that if you're like somebody has the door open in the shop or something, but it's not ideal. I've actually had to like block the wind with my hand before, like on very hot days where you're just suffocating in the shop. You don't want a contaminated weld because it will be ruined. So let's see what happens if we give it a little more wire feed. Okay, so you can see it looks pretty good. If we look at the back side, it'll have a different set of penetration to it. And you can see the welder has lost its song, right? And when the welder is set up properly, it sings to you. It hums like I don't even know, like a cicada or something like that, you know? It doesn't sputter, it doesn't spatter, it just sings to you while you're welding. And you can see this weld is higher, and it has more grooves and stuff in it, just because there's too much new material being shoved in there, and it's cooling off the weld as it's going on. And you can see I had to travel a little bit quicker in order to do the same thing. So we'll turn that back down to 1.5. Now we'll go up to E from D and increase the voltage and see what happens. Okay, different weld again, right? So you can see normal, high, low. So when we increase the voltage, it's still singing. This is an okay setting depending on what kind of weld you're doing. If you're doing a plug weld or you're doing a lap weld, you may need this extra amperage in order to get, you need that extra heat to get a nice weld. But you can see it's different, and the penetration on the back will be different as well, right? So it's not necessarily bad, but it's not ideal for what we're trying to do here, right? So let's look at the back side now, because that's what tells you everything. So you can see no gas, no penetration. You can see the too much well, I don't know, there's all kinds of weird stuff going on there. There's different things, right? And then you can see too much wire. We're missing some penetration. The penetration's blobby. And then the higher amperage, we get too much penetration, right? There's a lot of debate about what is the correct amount of penetration, but basically if you have penetration and it's consistent all the way along, that weld has maximum strength, right? Because it's all the way through. If you go further through, so you get more penetration, like this has like 3 millimeters width of penetration, probably about 2 millimeters high of penetration, all what you're doing is adding extra heat, creating a brittle material, right? So as soon as you have penetration all the way through, the metal will never crack on that weld. It'll crack right beside the weld where the metal has been superheated, but it doesn't have the strength of that high strength welding wire in it, right? If you add more wire, more heat, more weld, and more penetration, you're just adding more heat to the edge, so the edge just cracks sooner, right? So it seems weird, but this is not a strong weld, even though it looks like amazing. Too much penetration is not a good thing, because the weld sure is very strong, but right beside the weld in that heat effect zone is where it's going to fail, it's where it's going to break, right? So that's just a quick run through of the welder and the different settings. I'm not going to get into reversing polarity and all kinds of stuff like that. Like, it's literally never done in the body shop. If we want to switch to aluminum or silicon bronze, like every shop buys a specialized machine that's specially suited to it. So for the standard MIG welder like that, they're always run in this configuration. And really it's just these two knobs that we screw with to make stuff happen, right? Now the next thing about welding, so if we turn the welder back to our initial settings of 1.5D, and I'm going to show you what happens if you change your welder settings, okay? So it's not just the knobs on the machine, it's what you're actually doing with the torch as well, right? So the first thing I'm going to show you is angle. So normally I'm running at about the same angle as the gooseneck's on. I don't know what it is, like 30 degrees or something like that. So I'm going to run at a bit more, about 50 degrees, and let's see what happens. I'm going to go a little slower so we get good penetration. Okay, now I'm going to take away angle, and I'm going to go straight down, pretty much. Okay, now let's look at the back of this guy. Oh wow, they look really the same, and they shouldn't. So usually what happens when your demo doesn't mess up is the higher angle, the angle here, we're not pushing the wire into the metal, so the puddle is moving ahead. So we get a little more wire stick out, and we get a little less force of the heat into the panel. So usually you get less penetration. And then when you point straight down, you get a flatter weld with greater penetration. For some reason, when I did it, they both look exactly, well, you can see this one's a little bit more and that one's a little bit less. But you can just tweak the angle of your torch, and it's just like turning the knobs on the machine, right? So let's try another one again, and maybe there'll actually be a difference this time. So for this one, we're going to do stick out. So normally what we do is about 3/8 stick out, or basically the snipping it off with the pliers, like that's how much is sticking out. And that's about the distance we weld at. It's about a centimeter, a little more than a centimeter, right? So let's do a centimeter away weld. Okay, now I'm going to increase it, and I'm going to make it about a 2 centimeter distance weld. Okay, now, man, those look exactly the same too. Maybe I'm just like too good of a welder to make these differences work. I don't know. Maybe I'm just compensating and they look, well, Okay, they look the opposite of what they should look. So normally what you find is at 1 centimeter distance, you should have even penetration. At 2 centimeters distance, you should have less penetration and more weld height. Mine look the same, and then for some reason my closer one has less penetration than my far one. I don't know what the heck is going on, but that's what the textbook says, and that's normally what I find. I don't know what's happening today. Today is nothing is happening, or it's like totally backwards for some reason. So we have a couple of different things we can do. We can push, we can pull, we can change the stick out, the distance that we're welding to, and we can change the angle, and you can get subtle differences to the welds that you're doing. And there's certain types of welds that I do pulling. Almost all of them I do pushing. And then like plug welds and certain things you do at 90 degrees. Almost everything I'm doing at that 35-degree angle. It's nice where you can actually see your weld and so on and so forth, right? So a lot of welding is actually user preference. As long as you can get the full even penetration and not too much, you don't have any skips, you don't have any porosity, you don't have any like missed spots, you don't have any holes blown through, it's a good weld, right? And people will actually have different setups, and as well as different setups with your hand too, and actually create the same sort of type of weld, right? Because it's a balance of all these things together. It's kind of like with a spray gun. If you like hold it too far away when you're painting, it doesn't put enough paint on. But if you just go slower, then you can put the same amount of paint on, right? You go closer, you'll get runs. But if you speed up, it kind of looks the same when it's done, right? So it's sort of like that, okay? So next video, when I do a bunch of different welds, maybe I'll show you what I do anyways. And you guys got to try to figure it out for yourselves when you come here and start working in the lab, right? So that's it for today. Okay, so the cool thing, because everybody always says, why do we have to learn how to oxyacetylene weld? The cool thing about it is if you can learn how to oxyacetylene weld, which is pretty easy, you can learn how to TIG weld, which is really hard. And if you've never oxyacetylene welded before, learning how to TIG weld is twice as hard as learning if you already know how to oxyacetylene weld, right? So this welder is a little bit more complicated and can do a lot more things. I'll show you the cheat sheet for it. Sorry the torch is in the way, but this is the cheat sheet for a TIG welder. A little more complicated than the cheat sheet inside the Mig welder, right? So I'll show you how it's the same though, because all what this does is makes a puddle with an electric flame, an arc, instead of a actual gas flame, right? So I'll show you how similar it is. So we strike an arc just like the flame, and we create a puddle right there. See the puddle? And you just go along just like the torch. It almost looks like a flame coming out of the end of the tungsten. TIG stands for tungsten inert welding, right? And you just go along and make a bead like that, right? And it looks exactly the same. This is a piece of stainless steel, but it looks the same, right? You can just see that it has a smaller heat score because the flame is more controlled, it's more focused. And I'll show you when I add the rod, just like I added the rod, because you can see this is undercut now, right? Like the first flame weld was. So we'll add the rod and you'll see it looks pretty much the same. So there you can see the nice pretty TIG weld that everybody loves to see. You can do the exact same looking weld with the torch, it'll just be a little more boiled, and it'll be a little wider heat score because the flame does so much overheating, right? So that's something to be excited about. You guys get the TIG weld in level 3. If you get done your welding in level 2, you can try it out as well. So don't crap on the gas welding, because it's not done in the industry anymore. It's the core fundamental skills of fusing two metals together, creating and running a puddle. And once you understand those concepts, once you get how to make metal molten and control it, TIG welding is like a walk in the park. Like, you just use the little cheat sheet. It tells you a baseline for the settings, and you have the amperage roll on your foot. This is like how much flame is coming out, basically. The tungsten here, the gas lens coming over top of it, and then you feed the rod in. It's sort of like a combination of gas welding and MIG welding at the same time. So it's something to look forward to. The school has 2 of these TIG welders for you guys to play with.